All right, so it says the voltmeter shown has a full scale reading of 500 volts. The meter movement is rated for 100 millivolts and 0.5 milliamps. So what is the percentage of error in the meter reading if it's used to measure the voltage V in the circuit? So, so off of this, we know that the voltmeter has a resistance, an internal resistance. I guess Rm is accounted for one of them, and the this shown here, the meter movement also has one as well. So then, so since the meter movement is already rated for 0.5 milliamps, uh, we just use Ohm's law, right? Um, you know that the total, well, R is going to be resistance is going to be voltage divided by current. So the reading is 500, and then the meter movement is 0.5 milliamps. So 0.5 e to the negative 3. So if we plug that into our calculator, 0.5 e to negative 3, that's going to be, I think, this. Yeah. So I believe that's a million ohms. Yeah. So yeah, we have to account for that. So then if we account for that, realistically, we would have well, we'd have, if we were to measure V, we would have to account for an extra resistance, which is a million ohms, right? So then we would just have a million in parallel with 250K in parallel with 50K. So I can just, this is going to be what we measure. I'm gonna real quick, and then I'm gonna say this is our total. So we can just do that really quick. So we can say 1 over million plus 1 over 250,000 plus 1 over 50,000 is 40K of, yeah, 40K, 40,000. So 40,000, and then we have a 10 milliamp. So then our V, which would be the same here, across V would be the same here, or V would also be the same here. So then we can just say V is equal to I times R. So 10 times 40K. This is our V measured. So that would be, our reading would be 400 volts. But if we don't account for this, which I'm going to make more space, oops, make some space. And just, this would be our true value. We don't account for these, then we don't account for the million. So we're going to say 1 over 50,000 in parallel with 1 over 250,000 -1. Yeah, we would read, this would be our value. And, well, I just rounded it off, but I'm gonna round it off here. 10 milliamps. So then our voltage would be 10 milliamps times 41666.7, or whatever's in the calculator exactly. That would be 416.666667 ohms. So this would be our true, and this would be our measured. So then let's go ahead and do that. So we know this measured over true, right? So 400 over 416.667 minus 1 times 100, and that would be 416, yeah. Times 1,000 per 100. That would be negative 4.000000000. We got 68 and then 8. But we can just round this off to -4%. And that would be our answer.